Now let's discuss the PI controller. So the PI controller is simply to put together the P controller and the I controller. Transfer function of the PI controller is shown here. So we use PI controller to achieve low steady state errors. The most controllers implemented in practice. So if there is a I controller, and usually we will put a P controller together with I controller. So even though we discussed the I controller, so in usually I controller is not used alone. So we will use PI controller together. So it's because if we put the P controller, usually the response, the closed loop system will have a faster response than pure integral control. Then with the help of the I controller, it can raise the system to type 1 system. If the system is type 1 system, then it can reject completely constant bias disturbances. But if the plant is second order or higher order, then the PID controller is required. So PID controller basically means it has all the terms, a P controller, I controller, and a D controller. The transfer function of PID controller is KP, KIOS, and KDS. To illustrate the benefit of PID controller, let's still consider the transfer function of the motor. So in general, if we tune the parameters properly, then a PID controller has all the benefits of P controller, I controller, and D controller. We know a response of a system is determined by the location of poles. So we will use this example to show how the parameters Kp, Ki, Kt can determine the pole of the closed loop transfer function. This is the G, we know the D, we can write the D as controller of S, Kp S plus Ki plus Kd S. We know the denominator of the transfer function is also the characteristic equation. It will be multiplication of the numerator plus the multiplication of the denominator. S power 3 A1 S squared plus A2 S plus A KD S squared plus A KP S plus ki. So if we collect the term according to S, we have the characteristic equation shown here. So now we see we can adjust the value of kd, kp, and ki to arbitrarily determine the location of the poles. Theoretically speaking, so we can arbitrarily place the pole at any locations, unique locations, by choosing unique values kd, kp, and ki. But if we use the PI controller alone, then we can set kd to 0. Then we have two parameters for the PI controller. Then there are some restrictions where we can place the pole of the closed loop system, which basically determines the mode of the dynamic response.